This question is a worded question. It's a contextual question as well. It reads, the equation of the path of a ball thrown from the origin is y equals x, 12 minus x. That's the first sentence. Now, before I go any further, I'm going to see if I can get an idea about what this looks like. I can see that there's a root at 0, a root at 12. It's a negative quadratic, so it will look like that. I also know from working with quadratics that the vertex is halfway between the roots, so I could establish that that is going to be at 6. And I could even work out the height of that pretty quickly. 6 times 6 is 36. That gives me an idea. The ball leaves here, reaches a maximum height, and returns to the ground. Now, the next part of the sentence says, with units in meters, so this is going to be meters on this axis. The origin is at ground level. That's important to know. Oh, and there we go. Sketch this curve and find its derivative. So there's my sketch. And now to find the derivative, that's a simple two-step process. The first one is to expand this out. And the derivative is 12 minus 2x. Keep in mind that the direction of motion at any point is the direction of the tangent at that point. So at this case, the tangent is positive, the ball is going up. In this case, the tangent is negative, the ball is coming down. Now we have some questions to answer. How far from the origin does the ball land if the ground is level? If this is distance across, then we would say that it lands 12 meters away. Find the x-coordinate of the point H, where the direction of motion is horizontal. Direction of motion, that means, see here, it was going up, direction was up. Here is down, direction is down. Find the top bit. Find where the tangent has gradient 0. This one. We set y dash equal to 0 and solve. We already knew that. We could see that the vertex was halfway between the roots. So the maximum height, we already know too, was 36. What angle the ball was initially thrown? So that means if we find the gradient of the tangent there, then we will know that that is rise over run. We will be able to find the angle that it's thrown, knowing that tan theta will equal my gradient, where this is my angle of that tangent. So we need the gradient at the start, which is when x equals 0. Use my gradient function. When x is 0, y dash is 12. So my angle is equal to 12. And then I can find my angle. Let's reach for my trusty calculator. Now this says that it was thrown at 85.5 0.2 degrees. Show that on ground level it lands at the same acute angle to the ground. So now we need to find the gradient at x equals 12. Our gradient function is 12 minus 2x. So remembering we've got this and we're finding this gradient there, the angle there, but this is of course on this side. So they're the same angle but opposite directions, because one's going up, one's coming down.